Hey there and welcome to another Arduino tutorial. Today we're going to learn about two different switch configurations. So there are two ways that you can make switches and a third way which we won't go over, which uses internal pull-ups. But on a breadboard we can take this schematic and we are going to follow these schematic wires to make these connections. Now I already have it made, so through the course of this you can pause the video at any time and create this circuit in Tinkercad. The first thing that we're going to do is look at the schematic and see how these switches are wired. This is digital 3 and I have digital 3 right here. This is not digital 3, but this is actually digital 11, but I put a note that is connected to the digital 3 GPIO port. So following 5 volts, we need to connect 5 volts to a 1K resistor, and that's for D3. So that's what I've done here, is I've plugged the resistor directly into the 5 volt rail. And then this runs straight to digital 3 at this point. So we follow that right there. The switch is also connected to that point, and we have that right here. Now, on the same side of the switch, we also have a 10K resistor that runs directly to ground, and we have that simply right here. These switches do have two terminals that are connected internally, and that is the A and the A with the apostrophe, and B with the apostrophe as well. But on the other side, we have it connected directly to ground. So this one is active low, meaning when you push the switch, it will go low. So it is normally a high. So you see 5 volts coming in until you press the switch, which bypasses or shorts out this 10K resistor. So you have about 5 milliamps running through when you push this button. Normally, it's a negligible amount because when digital 3 GPIO is set to an input, it's high impedance, meaning that there's not much current draw. Now let's take a look at switch number 2. Switch number 2 is this one. That's on digital 7. The first thing we have to do is make a connection from digital 7 GPIO from the Arduino to the 1K resistor. And we've done that right here through the breadboard. The other end is connected to one of the tabs on the switch, which we have right here, terminal 1B. Now, my switches are backwards, and that's okay because switches are non-polarized. Now, we have 5 volts running to the other side of the switch. That's what this red wire denotes right here, is 5 volts running to the other side. We're just going to call it the other side. You can see 1B, 2B, so ignore that. These switches are backwards in Tinkercad. Then, from the junction of the 1K resistor to the switch, we also have a 10K resistor, which is right here, 10K resistor running straight to ground. So this one is normally low. You can see the path when the switch, dead end, when the switch is not pushed, it's to ground. So it sees 11K ohms to ground, which is fine. But when you push this switch, 5 volts comes in. This becomes a voltage divider, and it gives 90% of the high voltage of 5 volts goes straight into D7. Now that's some math that we don't have to go into today, because the same thing happens right here. 5 volts runs through this voltage divider, sending 4.5 volts to D3. So the hysteresis in this, and that's a big word, I know, but just know that 4.5 volts is considered a high. Now, if you're not careful with your component selection, 1K and 10K is safe. Stick with that. Now, on the other end of this, we have just simply 2 LEDs, and it doesn't matter really whether the resistor's on one side or the other. This is just the most common way that you'll see this. We have digital 11 is connected to a resistor. Digital 11 connected to the resistor runs through the anode of the LED, and the cathode is connected to ground, just like you see here. Either one of these connects to the 1K resistor through the diodes into ground. So now we have read the schematic. Now we need to write a program that actually works, because when you first start with the Arduino in Tinkercad, you're just going to have a very basic, the most basic program you can find. But we are going to use this to initialize all pins as inputs or outputs using pin mode. Now, LED built in is just a variable, and that variable, it holds pin 13. So pin 13 and pin 11 are outputs. So I'm double clicking 11, 13. Those are outputs. These two are going to be inputs. Now this all has to be in capital letters where we're typing right now. That is the syntax. But inputs are going to be pin 3 and pin 7. That's the first thing you have to do. Now, there is a quirk in Tinkercad where if you don't set these, it'll still work. It's weird, but it'll still work. But in real life, and I'll show you this built out on a real breadboard with the Arduino Mega 2560, and I'll show you how it works. But we're also going to use if statements. So anytime you need to make a decision, you can use an if statement, and the syntax looks like this. If, and we're using digitalRead this time, digitalRead, and the pin number is pin 3 that we're going to begin with. Then we go digital 3, and we know that this one is always 1, so unless you push the switch. So we're going to go if digital 3 equals 1, and I like to put some spacing. It doesn't matter if you do or not, but if digital 3 equals 11, if you're just going to put one statement, you do not have to use the braces, the curly braces, to do it. We're going to put it right on this line, and we're going to use digitalWrite, which will act as a switch, not the switches that we have over here, but it acts as a switch to turn on or off these two pins right here. So GPIO 11, digitalWrite 11 is going to be high. We're going to make that the default setting. If you swap it, try it out, see what happens. Else means if that statement that we just did, digitalRead 3, is not equal to 1, we are going to do the opposite. And you can make it do whatever you wanted to. But we're going to say else digitalWrite 11 low. Now, I don't want to have to copy and paste this whole thing, or type this whole thing. So I'm going to hit copy and paste. And I'm going to paste over all of this right here to get it to erase. And we're going to change this delay to 100. And now we're going to go digitalRead pin 7. If pin 7 equals 1, digitalWrite pin 13 as high. Else, meaning that if this is not a true statement, we are going to make digital 13 low. So that's the complete program. And the way this works is when the program begins, void setup says, okay, you want these two to be outputs and you want these two to be inputs. Internally in this chip, it sets a whole bunch of stuff that we don't have to worry about. We are not engineers right now. We are just programming. If digitalRead 3 equals 1, then we are going to digitalWrite 11 high. So as long as this is a 1, this one is going to be high. If digitalRead 7, pin 7, is high, we're going to write this as a high. Otherwise, we're going to write a low. So the state of these pins is this one, pin 3, is already high. So this LED should be on when we power up or simulate. This one, pin 7, is actually a low until we push the pin. So what's going to happen is this LED should be off. Now, if I've done this correctly and made no mistakes, we should be able to start simulation, and there's a mistake. So it says, I know where my mistake is. I forgot to terminate this with a semicolon. Now we can start simulation, and you can see that digital 3, because it is already high, because 5 volts flows straight to it, That one is on. This one is low because we don't have 5 volts coming through the switch. But if you push the switch, it turns on. If you push this switch, it turns off. So that is the desired effect that we're looking for here. Now, if you hold the shift key down and then click, it's like you have your finger on it constantly. So I'm pushing both of these switches at the same time, and you can see that it swaps. So that is how to use the different types of switches to create an output. Now, if you look at the video that I have posted just now, you will see that there is the same circuit built on a circuit board with the Mega 2560. And when I push these switches, you can see the same thing happens. If I hold both switches, it swaps. So have fun with this. Try out some other programs. Write whatever you want. See if it works or if it doesn't work. That's the whole trick to being in Tinkercad, is that you can write any program you want, test it out without having to go through the frustration of doing it on a breadboard. I'm Robbie, W1RCP. I hope this is helpful to get you to making programs that you might be able to use for amateur radio. Special thanks goes out to Scott Ward, Lansing, Michael, Kilo Echo 4 Eastern Standard Time, Josh, Kilo 4 Lima, India, Dale Henninger, Whiskey Zero Delta Hotel Zulu, Claude Ray, who is part of the Georgia Parks on the Air, that's georgiaparks.org, WD4DAN, Front End Overload, and the longest standing member, Toby, Alpha Delta 2, Charlie Delta. Without you guys, I could not continue doing these kinds of things and projects. Thank you so much for your support. Don't forget to watch the next video that is suggested for you.